Now we're going to talk about the concept of limiting reactants. So when you make sandwiches at home, do you always have exactly the right amount of bread and meat and cheese to make exactly the right number of sandwiches? No. Sometimes, hopefully most of the time, you've got extra stuff left because you didn't use up all of any of the ingredients. But if you're making a lot of sandwiches, you're going to run out of one thing. And so let's just do this example. Here's our recipe for a sandwich. 2 slices of bread, 3 slices of meat, a slice of cheese makes 1 sandwich. So if we have 50 slices of bread, 60 slices of meat, and 40 slices of cheese, how many sandwiches can we make? Now this is a somewhat practical problem, right? If you're making sandwiches for the football team or something, how do we figure this out? Well, let's look at each of the ingredients and figure out how many sandwiches we could make. Okay? Because, well, yes, you could just start making sandwiches and see what happens, but then you don't have enough time to go back to the store, and you don't want to buy extras that's going to get moldy or rotten and waste a lot of money. So you need to know. So if we have 50 slices of bread, how many sandwiches can we make? Well, we get 1 sandwich for every 2 pieces of bread, right? So 1 sandwich per 2 slices of bread. So we could make 25 sandwiches if we have enough of the other ingredients. These words are way too long. 25 sandwiches. Okay. So if we have 60 slices of meat, for every 1 sandwich, how many slices of meat do we need? 3. 3 slices of meat. I'm sorry, this is so messy. So 60 divided by 3 is 20, right? So 20 sandwiches. So if we run out of meat after 20 sandwiches, can we make 25 sandwiches? No. They could be cheese sandwiches, but you're going to get fired if you do that. Yeah. So what about the cheese? 40 slices of cheese and 1 sandwich for 1 slice of cheese, right? So if we were able to use up all the cheese, we could make 40 sandwiches. But how many sandwiches can we actually make? We can only make 20. We can make the smallest number, right?
We could double up on cheese.
Let's not get carried away. So we're going along making sandwiches. And we make 10 sandwiches and 15 sandwiches. And when we get to 20 sandwiches, we run out of meat. We are done. We can't make any more. What gets left over then? There's bread and cheese left over. Okay? So there's going to be stuff left over. But this is how many sandwiches we can make. We're going to do a similar process with chemicals. We had a little discussion last week about, well, what about the leftover oxygen when you're burning propane? What about that? Well, this is what happens. One thing gets used up. When one ingredient is used up, production stops. Okay? You make cakes, birthday cakes or cupcakes. The bad thing about these large class sizes is you need to make 2 boxes of cake mix to make enough cupcakes for the 1 class. It's really annoying, especially when you have to do it multiple times. Anyway, that's my own personal problem. It's birthday season at my house. So you run out of something, and then what happens? You're done. You can't make any more.
If
your cows, if your kids were cows, you would technically have a dairy by law.
By law? That's good to know. If my kids were cows, then technically I would have a dairy. That's good to know. Thank you.
So you
I have a herd. I have a herd of
yes,
children.
You have a herd.
I have a herd. Yeah. Thank you. That's good.
I'm just putting it in perspective for it.
I was
Six
thinking a
kids equals one
litter,
herd.
but
One U equals one herd.
yeah. So there we go. So we could do dimensional analysis
Yeah.
with that, right? So in that example, the meat was the limiting ingredient or the limiting reactant. The meat limited how much we could make. So the limiting reactant limits how much product you can make. Let's look at a different situation. This is called a stoichiometric mixture, where we have exactly the right amount of stuff. So here we have illustrations, because pictures are great. So nitrogen reacting with hydrogen gas to form ammonia gas. So here is the balanced chemical equation. We need 1 nitrogen molecule and 3 hydrogen molecules to make 2 ammonia molecules. And so here in this container, here's our little legend. The little blue ones are the hydrogens, the big darker blue ones are the nitrogens, and the funny looking ones are the ammonia. So here they have grouped these. So 1 nitrogen and 3, let's doing it again, 3 hydrogen molecules. That could make 2 ammonia molecules over here. And this 1 nitrogen and 3 hydrogens is going to make 2 ammonia molecules over there. So you can imagine these balls, you just pull them apart and you stick them together differently and you've got ammonia. And that's a great way to picture what's going on. That atoms are marbles or little sticky balls and you can stick them together in different ways. Here's another group and another group and another group. Here we have just the right number of hydrogen molecules and nitrogen molecules. And so when we get over here, arrow, move, come on. When we get over here, we don't have any of the reactants left over. They all reacted. This is, think about in your kitchen, you're going to make anything. How often does that happen? Where you use up all the ingredients at the same time? It doesn't happen, right? It doesn't happen much in chemistry either. How come the picture doesn't match the equation? How does it not match the equation? Okay, but this is giving us the ratio. For every one of these, we make 2. That's the ratio.
That would be the reaction for like one of those little red dotted circles, like just one.
Say that again?
So this would tell the numbers in this circle going to that circle. But like we didn't make just 1 sandwich. We ended up making 20 sandwiches. So it's just multiplied. So we're just scaling up the recipe.
So that's just the basic.
Yeah, the balanced chemical equation, and that's a very good point. The balanced chemical equation gives us the simplest ratio of molecules or moles of molecules of each reactant and product. It doesn't say this is how many you have in a given reaction. It's a general thing, okay? And just like sandwiches, you could use the same recipe and make 1 sandwich or 10 sandwiches or 100 sandwiches or 5,000 sandwiches. The same recipe applies to all. You just multiply it to get more. And so it's a lot more useful that way.
So if you order the reaction by 4, it should be like you multiply the entire reaction by 5.
Yeah.
Okay, that's what I was.
Okay, so in fact, let's do that. So how many nitrogen molecules are there in the reactant vessel there? There's 5, right? So there's 5 of those, and there's what, 15 hydrogens? And then over here, there's going to be 10. Well, if we take those numbers and divide them by 5, what do we get? We get 1, 3, and 2. So what's pictured here is just the reaction, the recipe, times 5. Okay? This is a picture of what's more likely to happen, where we don't have exactly the right amounts of all the ingredients. There it is. So here is one group that's stoichiometric, 3 hydrogens for 1 nitrogen, and that will make 2 ammonias over here. And here we can group these guys together and see that they will make 2 ammonias over here. And these guys will make 2 ammonias over here. And what about these 2 nitrogen molecules? What happens to them? Nothing happens to them. When you make the sandwiches and you run out of meat, what happens to the bread? It's just sitting there. It's still there. It's not part of a sandwich. It's still bread. What happens to the cheese? It's still there. And hopefully you remember to put it away and so you could do something with it later. But so those nitrogen molecules are just still there. Okay? Does that bother anybody?
Yeah.
Yeah. You said that just because.
That's because I'm just gonna ignore it.
So things, life isn't perfect. We would like everything to be neat and work out just perfectly, and it doesn't. It just doesn't. And so you just have to go with it.
Is that just because of variations in math of literally measuring?
Is that because of variations in measuring? Yeah, if you go to the particulate level and actually look like we are here at individual molecules, the chances of you being able to get exactly the right number of molecules of each substance together is highly unlikely. I mean, it would just be really, really hard to do. Could you get close? Yeah, you could get close. Most of the time, though, it's not worth the effort to get close.
So, say you do a chemical reaction,
Mm-hmm.
like any of the ones that we did, and then you were to actually take an analysis of what was left over, there would still be traces of original elements, basically.
Yes.
Is what that is saying.
Yeah. And then just to make things even more complicated, not all reactions go to completion.
Oh, thanks.
Yeah. Just had to throw that in there, sorry.
So we only know that that's a limiting reactant mixture because you told us, because
Like, no
that's
matter
a simple
what?
equation. That's the balanced equation
Some do.
still.
It's the balanced equation. The only way you would know that there was something left over is if I told you something about the amounts. Okay, like with the bread.
Is it combustion reactions that do?
So it's like when you're making a recipe. So you're making sandwiches. And sometimes, if you've got enough stuff to make 100 sandwiches, are you necessarily going to end up with 100 sandwiches? No, because, you might have sneezed on one. You had to throw that one out. Or maybe you dropped one on the floor. Or a bird flew into your kitchen and pooped on one. I mean, things happen, right? It could happen. The cat could jump up on the counter when you went to use the restroom and eat some of the meat. I mean, things could happen. Okay, come back to me. I still have a minute. And I'm not done yet. So here, let's look at this. This is the one we were just looking at. So what we would say is that the hydrogen is the limiting reactant. Because the hydrogen limited how much? We ran out of hydrogen. Just like we ran out of the meat making the bread. You don't use meat to make bread. Making sandwiches. The thing that you run out of, that you completely use up, is the limiting reactant. And that limits the product, hence the name. It's the reactant that limits. It's the limiting reactant. How clever is that? Which slide? This one?
Yeah. That's the one.
So we use up all the hydrogen, and there's some nitrogen left over.
So the limiting one is the one that's,
The limiting one is the one that gets used up.
yeah.
So the hydrogen got used up.